Hello Year 9. Hope we had a lovely half term. We are continuing on with the C1 atomic structure topic. We've moved past the periodic table and we're going to look at some models of the atom. Because we talk about atoms all the time, and we talk about elements being a substance that's made up of only one type of atom. But what is an atom? So that's what we're going to do in today's lesson. So there's today's work folder. There's a lot of stuff in there. I will go through what each one is when it gets towards the end of the lesson, because you won't need all of it. First thing I'm going to go on to is the PowerPoint. So here it is. Now, the title is Models of the Atom. We're not doing anagrams because we're not in the lesson. It would have been a nice little starter. Instead, there's a video here that I'd like you to watch. So if you just go on the PowerPoint, you click play. It's about 6 minutes long. It goes into quite a lot of detail of, it's like a very quick recap of the whole different models of the atom, who made the model and what did the model look like. But the two main ones that you've got to know, as in you need to know everything about them, are the Plum Pudding model. Okay, so here's the information on the Plum Pudding model. I'm not going to go over it just yet because there is more information to go. Everything on this slide is pretty much what you need to know about the Plum Pudding model. 3 bullet points there. The atom is positively charged, and it's a soup. The negative charged things are called electrons, and the mass is evenly distributed, and there's a diagram you'll have to be able to draw and label. I'm going to move on to the Bohr model now. So the Bohr model here, or the nuclear model. It's called the nuclear model because they proposed that a nucleus exists. And so, yeah. Now, so again, positively charged nucleus in the center, negatively charged electrons, and the mass of the atom. So they're the 3 things that you need to know about for each model. Well, you have to be able to draw and label a diagram. You need to know how the positive charge is distributed, how the negative charge is distributed, and how the mass is distributed. They're the 3 important things. If you look at both of them, it's different. Now, I'm going to skip past this because I'm going to tell you the task that you need to do. So here's kind of like a timeline. First models of the atom were proposed back in 460 BC and Dalton in 1800. Then the Plum Pudding was done by Thomson in 1897. Then we've got the Rutherford model of the atom in 1912 and the Bohr model of the atom in 1913. There is a new one, we call it the quantum model, but we don't really need to learn about that for GCSE. So I'm just going to leave the PowerPoint now. Now, there are some questions here. So this one, questions on model of the atom. Okay, I'd like to try and answer these questions, but you might need some extra notes. So here, it goes into a bit more detail. And here, if I minimize this one, 4.3, is pretty much as little, all the important information. Like I've trimmed it right down so it's only got the bits of information that you need. So you can see there, you've got the Plum Pudding model on the left and the Bohr model on the right. Okay, so I'm going to get rid of that and I'm going to go to the PowerPoint. So again, here is a very in detail timeline of what happened. One thing I will say is, it's all self-explanatory, but when you get onto Rutherford, okay, we need to know about his experiment, which I will go into in a bit. But if you just look at the atom, let me just maximize here so I get the pointer out. If you look at the atom, this is different from the picture I've shown you already. You see the electrons are dotted around, and this in the center there's a positive charged sort of lump. Okay, a positive charged nucleus. In the diagrams that you've seen, you will know that there are protons and neutrons in there. The first model, the Rutherford model of the atom, okay, started off with just a positive nucleus because we did not know what neutrons were. So I'll go back here. See that the electrons are kind of dotted around. Then Niels Bohr comes along. He suggested that the electrons orbit in certain shells. So they weren't just dotted around the outside, they orbited the shell. So they orbited the nucleus at a fixed sort of distance. So then this model here, where it was kind of dotted, the electrons were kind of dotted around, changed into the still positive nucleus, but the electrons went around on shells, like this. Okay, so the model sort of advanced a little bit. Then, later on, someone called James Chadwick came along. Here he is. Basically, all you need to know about him is he is the one that discovered the neutron. Okay, so James Chadwick discovered the neutron. So we started off with, sorry, my pen's just being funny. Pen, there it is. So we started off, okay, the Rutherford model had a positive lump in the middle with electrons dotted randomly around the outside like this. Then Niels Bohr came along and he said, actually no, we've got the positive lump in the middle, but the electrons orbit in shells like this, okay? And then Chadwick came along and he was puzzling about the different masses of the atoms. How could they have different masses? There must be something else in there. And he figured out how to detect a new particle. And then he changed the model very slightly. So instead of being that positive lump, you have got a nucleus with positive protons and zero charge or neutral neutrons with the electrons orbiting around the outside. So you can see even though these models are very, very similar, you can see how they've progressed. Now this is the one that you've got to learn. You've got to be able to draw and label it, but you've got to understand where that model came from. So I will get rid of this. So what I'd like to do now is have a go at this worksheet. So it's just a very quick memory recall. You have to be able to draw and label. You've got to be able to compare. It's really the hardest question I'll ask you. Remember, you've got to compare the three things. You've got to compare the positive charge, you've got to compare the negative charge, and you've got to compare the mass. Okay, so they're the three things you need to compare when you are comparing the Bohr model and the Plum Pudding model. Now, there is one other thing. So when I said that before the nucleus was discovered, we thought it was a plum pudding model. So the plum pudding model was thought to be a soup of negative charge, sorry, a soup of positive charge with negative electrons dotted randomly through it. Okay, so I will get that up. Here it is. Right, so there is the plum pudding model, right? You can see there's that soup of positive charge with electrons dotted randomly. The way that Rutherford disproved this model and changed it to his one with the positive nucleus in the middle is he did this experiment. It's called the gold leaf experiment. He fired alpha particles, and an alpha particle is just 2 neutrons and 2 protons. Okay, it's this type of radiation. He fired the alpha particle, or they called it helium nucleus back then as well, because it is just a helium nucleus, at a thin foil. Okay, so the thin gold foil. And what was supposed to happen is if it was just a soup of positive charge, all of the alpha particles would pass straight through and not even really change direction. Okay, because that thin soup, the alpha particles would just cut straight through it. What actually happened was about 1 in 8,000, I believe. Sorry, 1 in 10,000 particles were deflected by more than 90 degrees. So essentially the alpha particle went along, so I'm going to zoom in a little bit. The alpha particle went into this vacuum chamber here, and it bounced back off the foil and was detected over here somewhere. Now, Rutherford described that as firing a cannonball at a piece of paper and the cannonball bounced back because it was so completely against everything they believed at the time, which he then used that information to come up with something like this, saying that the nucleus is small and dense. Now, how did he do that? Well, there are 2 different things that you need to know. If you are told to describe the results of the Rutherford's scattering experiment, you need to know these 3 bullet points here. Okay, but then you to understand that if he, after he has seen this, this is what he deduced. Okay, so from this observation of most of the alpha particles passed straight through the metal foil, he could say that the most of the atom is empty space. Okay, because some particles deflected, he could say that the nucleus is positively charged. And because about 1 in 10,000 particles were bounced back, he could say that the nucleus is very, very small and dense. Okay, so I'm going to renumber these so that they're in the right order, so you can see how they directly link to each other. So that is what you need to know. Could you make sure you fill in that worksheet, please? Have a little read through the Rutherford's gold leaf experiment, and then email it back to me. And then you are done.